Hello guys, today we are going to see Web Applications Basics room. This room will help us understand how HTTP protocol works, its request methods and response codes. Let's go into task 1. Introduction. Welcome to the Web Applications Basics room. In this room we will walk through the key elements of web applications such as URLs, HTTP requests and responses. This is perfect if you are starting and want to get a handle on the essentials, or if you are looking to build or work with web apps. So the learning objectives are: we are going to learn how HTTP requests and responses work and get familiar with different types of HTTP requests and responses that can be made. Let's jump into task 2, web application overview. Consider an analogy of web application as a planet. Astronauts travel to the planet to explore its surface, similar to how someone uses a web browser to explore or browse a web application. Although we can only see the surface of a planet, a lot is going on under the surface. You can imagine the whole planet as a web server with many things going on under the surface of the web server. Yet we all can usually see is the surface of web pages or apps. We will now explore the various components that make up a web application. Front end. The front end can be considered similar to the surface of the planet, the parts that an astronaut can see and interact with based on the laws of nature. A web application would have a user interact with it and use a number of technologies such as HTML, CSS and JavaScript to do this. So HTML is the foundational aspect of web application. It is a set of instructions or code that instruct a web browser on what to display and how to display. Now let's jump into CSS. CSS describes a standard appearance such as certain colors, types of text and layouts for the web application. Now coming to JavaScript. JavaScript in front end enables more complex activities in the web browser. Whereas HTML can be considered a simple set of instructions on what to display, JavaScript is more advanced set of instructions that allow choices and decisions to be made on what to display. In the planet analogy, JavaScript can be considered the brain of an advanced organism, which allows decisions to be made based on what and how something interacts with it. Backend. Coming to backend of a web application is things we don't see within a web browser but are important for the web application to work. For example, databases. A database is where information can be stored, modified and retrieved, and many other infrastructure components such as web servers, application servers, storage, various networking devices, etc. And finally, web application firewall, which is an optional component, but it helps filter out dangerous requests away from web server and provide element of protection. These are many components involved in delivering a web application. Front-end components like HTML, CSS and JavaScript focus on the experience inside the browser. Backend components such as web server, database or WAF are the engine under the surface that enable the web application to function. This simple introduction will be built upon the upcoming tasks. Okay, now let's answer the questions below. Which component on a computer is responsible for hosting and delivering content for web application? So to host and deliver content we need a server, so the answer is web server. Which tool is used to access and interact with web applications? We would need a web browser. Which components act as a protective layer, filtering the incoming traffic to block malicious attacks and ensuring the security of the web application? It is WAF, Web Application Firewall. Now let's move on to task 3, Uniform Resource Locator. A uniform resource locator URL is a web address that lets you access all kinds of content, whether it's a web page, a video, a photo, or another media. It guides your browser to the right place on the internet. Anatomy of the URL. So we have a scheme, a user, host or domain, then port number, then path, and query string and fragment. Let's break down each of the component. Scheme. The scheme is the protocol used to access the website. The most common are HTTP and HTTPS. HTTPS is more secure because it encrypts the connection, which is why browsers and cybersecurity experts recommend it. Websites often enforce HTTPS for added protection. Next, user. Some URLs can include a user's login credentials, usually a username. For sites that require authentication, then this happens mostly in URLs that need credentials to access certain resources. However, it is rare nowadays because putting login details in the URL isn't very safe. It can expose sensitive information, which is a security risk. Next, host or domain. The host or domain is the most important part of the URL because it tells you which website you are accessing. Every domain name has to be unique and is registered through domain registrars. For a security standpoint, looking for domain names that appear almost like real ones but have small differences. This is called typo squatting. These fake domains are often used in phishing attacks to trick people into giving up sensitive info. Next, port. The port number helps you direct your browser to the right service on the web server. It is like telling the server which doorway to use for communication. Port numbers range from 1 to 65,535, but the most common are 80 for HTTP and 443 for HTTPS. Next, path. The path points to specific file or page on the server that you are trying to access. It is like a roadmap that shows the browser where to go. Websites need to secure these paths to make sure only authorized users can access sensitive resources. Next, query string. The query string is the part of the URL that starts with a question mark. It's often used for things like search terms or form inputs. Since users can modify these query strings, it is important to handle them securely to prevent attacks like injections, where malicious codes could be added. Fragment. The fragment starts with hash symbol and helps point to a specific section of a web page. It's like directly jumping to a particular heading or a table. Users can modify this too. So like with query strings, it is important to check and clean up any data here to avoid issues like injection attacks. Okay, now let's answer the questions below. Which protocol provides encrypted communication to ensure secure data transmission between a web browser and a web server? It is HTTPS. What term describes the practice of registering domain names that are misspelled variations of popular websites to exploit users' error and potentially engage in fraudulent activities? It is called typo squatting. What part of a URL is used to pass additional information such as terms or form inputs to the web server? It is query string. Now let's move on to task 4, HTTP messages. HTTP messages are packets of data exchanged between a user and the web server. These messages are very important for understanding how web applications work because they show how users' requests and the server's responses are communicated. Imagine an example of an HTTP request and a HTTP response, where you can see key parts like the method, URL, headers, and status codes. These are what makes the client-server interaction possible. There are two types of HTTP messages: HTTP requests, which are sent by the user to trigger action on the web application, and HTTP response, sent by the server in response to the user request. We can see the examples of both HTTP response and HTTP request and response. Each message follows a specific format that helps both the user and the server communicate smoothly. Start line. The start line is like the introduction of the message. It tells you what kind of message is being sent, whether it's a request from the user or a response from the server. This line also gives important details about how messages should be handled. Headers. Headers are made up of key value pairs that provide extra information about the HTTP message. They give instructions to both the client and the server handling the request or response. These headers cover all sorts of things like security, content types, and more, making sure everything goes smoothly in the communication. Empty line. The empty line is a little divider that separates the header from the body. It is essential because it shows where the header stops and where the actual content of the message begins. Without this empty line, the message might get messed up and the client or server could misinterpret it, causing errors. Body. The body is where the actual data is stored, like a request. The body might include data the user wants to send to the server, like form data. In a response, it's where the web server puts the content that the user requested, like a web page or API data. Why understanding HTTP messages matters. These messages are the foundation of how web applications communicate. If they are structured properly, everything works smoothly. Knowing how they work will help you diagnose issues in web communication, which means better performance and reliability for your web application. It's also crucial for security. Understanding HTTP messages helps you implement strong security measures to protect data during transmission. Now let's answer the questions below. Which HTTP message is returned by the web server after processing a client's request? So it is called HTTP response. What follows the header in an HTTP message? So the headers are followed by an empty line. Now let's move on to task 5, HTTP request line and methods. An HTTP request is what a user sends to a web server to interact with a web application and make something happen. Since these requests are often the first point of contact between the user and the web server, knowing how they work is super important, especially if you are into cybersecurity. So this is the example of a HTTP request. We have a HTTP method, we have a path, and we have the version of HTTP. So these are the HTTP headers with their values accordingly. Imagine an HTTP request showing the key parts like the method, example get or post, path, for example /login, and version, for example 1.1. These elements make up the basics of how a client communicates with server. Request line. The request line is the first part of HTTP request and tells us the server what kind of request it's dealing with. It has three main parts: the HTTP method, the URL path, and the HTTP version. So this is the request line or the start line. HTTP methods. The HTTP method tells the server what action the user wants to perform on the resource identified by the URL path. Here are some of the most common methods and their possible security issues. Get. Used to fetch data from the server without making any changes. Reminder, make sure you are only exposing data the user is allowed to see Avoid putting sensitive info like tokens or passwords in GET requests since they can show up as plain text. Next, post sends the data to the server, usually to create or update something. Reminder, always validate and clean the input to avoid attacks like SQL injection or excesses. Put replaces or updates something on the server. Make sure the user is authorized to make changes before accepting the request. Next, delete. Remove something from the server. Just like put, make sure only authorized servers can delete resources. Now, besides these common methods, there are few others used in specific cases. Example, patch, which updates parts of a resource. It is useful for making small changes without replacing the whole thing, but always validate the data to avoid inconsistencies. Next, head works like get but only retrieves headers, not the full content. Next, options tells you what methods are available for a specific resource, helping clients understand what they can do with the server. Next, trace. Similar to options, it shows which methods are allowed, often for debugging. Many servers disable it for security reasons. Connect. Used to create a secure connection, like for HTTPS. It's not as common but is critical for encrypted communication. Each of these methods has its own security rules. For example, patch request should be validated to avoid inconsistencies, and options and trace should be turned off if not needed to avoid possible security risks. Next, URL path. The URL path tells the server where to find the resource the user is asking for. For instance, in the URL tryhackme.com/API/users/123, the path API users123 identifies a specific user. Attackers often try to manipulate the URL path to exploit vulnerabilities, so it is crucial to validate the URL path to prevent unauthorized access, sanitize the path to avoid injection attacks, protect sensitive data by conducting privacy and risk assessments. Following these practices helps protect your web application from common attacks. Now, let's move to HTTP version. The HTTP version shows the protocol version used to communicate between the client and server. Here's a quick rundown of the most common ones. So, the first version of HTTP is 0.9. Only supports GET requests. Then HTTP 1.0, where headers are added and better support for different types of content improved, and also caching is also improved. Then comes HTTP 1.1, which brought persistent connections, chunked transfer encoding, and better caching. It's still widely used today. Then HTTP version 2 introduced features like multiplexing, header compression, and prioritization for faster performance. The latest version is HTTP 3, which is built on HTTP 2 but uses a new protocol, QUIC, for quicker and more secure connections. Although HTTP 2 and 3 offer better speed and security, many systems still use HTTP 1.1 because it's well supported and works with most existing setups. However, upgrading to HTTP 2 or 3 can provide significant performance and security improvements as more systems adopt them. Okay, let's answer the questions. Which HTTP protocol version became widely adopted and remains the most commonly used version for web applications? Known for introducing features like persistent connections and chunked transfer encoding, it is HTTP 1.1. Which HTTP request method describes the communication options for target resource, allowing clients to determine which HTTP methods are supported by the web server? It is options. In an HTTP request, which component specifies the specific resource or endpoint on the web server that the client is requesting, typically appearing after the domain name in the URL. So it is URL path. Now let's move on to task number 6, HTTP request headers and body. Request headers. Request headers allow extra information to be conveyed to the web server about the request. Some common headers are host, which specifies the name of the web server the request is for. Next, user agent shares the information about the web browser the request is coming from. Next, the referrer indicates the URL from which the request came from. Next, cookie information the web server previously asked the web browser to store is held in cookies. Next, content type. It describes what type of format of data is in the request. Now request body. In HTTP requests such as post and put, where data is sent to the web server as opposed to requested from the web server, the data is located inside the HTTP request body. The formatting of the data can take many forms, but some common ones are URL encoded, form data, JSON or XML. URL encoded, that is application slash x www form URL encoded, a format where data is structured in pairs of key and value, where key equal to value in structure. Multiple parts are separated by an ampersand symbol, such as key 1 equals to value 1 and key 2 equals to value 2. Special characters are percent encoded. For example, name equals to Alex and Alexandra, ampersand age equals to 27, ampersand country equals to US. Next, form data. Multi-part form data allows multiple data blocks to be sent, where each block is separated by a boundary string. The boundary string is defined header of the request itself. This type of formatting can be used to send binary data such as uploading files or images to web server. So this is the example of form data. Next, coming to JSON. In this format, the data can be sent using JSON, JavaScript object notation structure. Data is formatted in pairs of name with semicolon value. Multiple pairs are separated by commas. All are contained within curly braces. This is the example of JSON data. Next, XML. In XML formatting, data is structured inside labels called tags, which have an opening and closing. These labels can be nested within each other. You can see in the example below the opening and closing of the tags to send details about a user called Alexandra. This is the example of XML data. Now let's answer the questions. Which HTTP request header specifies the domain name of a web server to which the request is being sent? So it is host. What is the default content type for form submissions in HTTP request, where the data is encoded as key equal to value pairs in query string format? It is URL encoded. So let me copy it from here. Which part of a HTTP request contains additional information like host, user agent and content type, guiding how the web server should process the request? It is request header. Okay, let's move on to task 7. HTTP response, status line and status codes. When you interact with a web application, the server sends back an HTTP response to let you know whether your request was successful or something went wrong. These responses include a status code and a short explanation called the reason phrase that gives insight into how the server handled your request. Status line. The status line in every HTTP response the first line in every HTTP response is called the status line. It gives you three key pieces of info: HTTP version that is being used, the status code which is a 3-digit number showing the outcome of your request, and the reason phrase which is associated with the outputted status code. Since we already covered HTTP versions in task 5, let's focus on status codes and reason phrases. The status code is a number that tells you if the request succeeded or failed, while the reason phrase explains what happened. These codes fall into 5 main categories. Informational responses, that is from number 100 to 199. These codes mean the server has received part of the request and is waiting for the rest. It is a keep going signal. Next, successful responses, that is from 200 to 299. These codes mean everything worked as expected. The server processed the request and sent back the requested data. Next, redirection messages, that is 300 to 399. These codes tell you that the resource you requested has moved to a different location, usually providing the new URL. Client error responses, that is from 400 to 499. These codes indicate a problem with the request. Maybe the URL is wrong or missing some required info like authentication. Next, server error responses, which is from 500 to 599. These codes mean server encountered an error while trying to fulfill the request. These are usually server side issues and not the client's fault. So here are some of the most frequently seen status codes. 100 for continue. The server got the first part of the request and is ready for the rest. 200, which is okay. The request was successful and the server is sending back the requested resource. 301, moved permanently. The resource you are requesting has been permanently moved to a new URL. Use the new URL from now on. Next, 404, not found. The server couldn't find the resource at the given URL. Double check that you have got the right address. Next, 500, internal server error. Something went wrong on the server's end and it could not process your request. Okay, these are some of the common status codes that can be seen on HTTP response. Let's answer the given questions. What part of an HTTP response provides the HTTP version, status code, and a brief explanation of the response outcome? So, what part? It is status line. Which category of HTTP response codes indicate that the web server encountered an internal issue or is unable to fulfill the client's request? Unable to fulfill the client's request, that means it is from the 500 to 599 range server error responses. Which HTTP status code indicates that the requested source could not be found on the web server? It is 404. Let's move on to task number 8. HTTP response headers and body. Response headers. When a web server responds to a HTTP request, it includes HTTP response headers, which are basically key value pairs. These headers provide important info about the response and tell the client how to handle it. Picture an example of HTTP response with the headers highlighted. Key headers like content type, content length, and date give us important details about the response the server sends back. So this is the example of a HTTP response with headers. Required response headers. Some response headers are crucial for making sure the HTTP response works properly. They provide essential info that both the client and server need to process everything correctly. Here are few important ones. Date. This header shows the exact date and time when the response was generated by the server. Content type. It tells the client what kind of content it is getting, like whether it is HTML or JSON or something else. It also includes the character set like UTF-8 to help the browser display it properly. Server. This header shows what kind of server software is handling the request. It is good for debugging, but it can also reveal server information that might be useful for attackers. So many people remove or obscure this one. Other common response headers. Besides the essential ones, there are other common headers that give additional instructions to the client or browser and help control how the response should be handled. Example, set cookie. This one sends cookies from the server to the client, which the client then stores and sends back with future requests. To keep things secure, make sure cookies are set with the HTTP only flag so they can't be accessed by JavaScript, and the secure flag so they are only sent over HTTPS. Next, cache control. This header tells the client how long it can cache the response before checking with the server again. It can also prevent sensitive info from being cached if needed using no cache. And location. This one's used for redirection responses. It tells the client where to go next if the resource has moved. If users can modify this header during requests, be careful to validate and sanitize it. Otherwise, you could end up with an open redirect vulnerabilities where attackers can redirect users to harmful sites. Response body. The HTTP response body is where the actual data lives, like HTML, JSON, images, etc., that the server sends back to the client. To prevent injection attacks like cross-site scripting, always sanitize and escape any data before including it in the response. Okay, now let's answer the questions. Which HTTP response header can reveal information about the web server software and version, potentially exposing it to security risks if not removed? It is server. Which flag should be added to cookies in the set cookie HTTP response header to ensure that are only transmitted over HTTPS, protecting them from being exposed during unencrypted transmissions? So the flag is secure. Which flag should be added to cookies in the set cookie HTTP response header to prevent them from being accessed via JavaScript, thereby enhancing security against XSS attacks? So it is HTTP only. Okay, now let's move on to task number 9, security headers. HTTP security headers help improve the overall security of the web application by providing mitigations against attacks like cross-site scripting, clickjacking, and others. We will now dig deeper into the security headers. Content Security Policy (CSP), Strict Transport Security (HSTS), X Content Type Options, Referrer Policy. You can use a site like securityheaders.io to analyze security headers of any website. After the discussion in this task, you will hopefully have a better understanding of what is reporting on. Okay. Content Security Policy (CSP). A CSP header is an additional security layer that helps mitigate against common attacks like XSS. Malicious code could be hosted on a separate website or a domain and injected into the vulnerable website. A CSP provides a way for administrators to say what domain or sources are considered safe and provide a layer of mitigation to such attacks. Within the header itself, You may see properties such as default source or script source defined and many more. Each of these give an option to an administrator to define at various levels of granularity what domains are allowed for what type of content. The user of self is a special keyword that reflects the same domain on which the website is hosted. Look at an example of CSP header. Default source self, script source self, and the URL is cdn.tryhackme.com, and style source is also self. We see the use of default source, which specifies the default policy of self, which means only the current website. Script source, which specifies the policy for where scripts can be loaded from, which is self, along with scripts hosted on http cdn.tryhackme.com. And style source, which specifies the policy for where style CSS sheets can be loaded from the current website. Strict transport security, HSTS. The HSTS header ensures that web browsers will always connect over HTTPS. Let's look at an example. Max age. We can see the parameters such as max age with an integer, include subdomains, and preload. Here is the breakdown. Max age. This is the expiry time in seconds for the setting. Include subdomains, an optional setting that instructs the browser to also apply these settings to all subdomains. Preload. This optional setting allows the website to be included in preload list. Browser can use preload list to enforce HSTS before even having their first visit to a website. Next, X content type options. The X content type options header can be used to instruct browsers not to guess the MIME time of a resource, but only use the content type header. So, MIME, Multi-Purpose Internet Mail Extensions, is an internet standard that extends the format of email messages to support text in character sets other than ASCII, as well as attachments of audio, video, images, and application programs. Okay, here is the example of X content type options. We can see the header no sniff. No sniff means this directive instructs the browser not to sniff or guess the MIME type. Let's move to referrer policy. This header controls the amount of information sent to the destination web server when a user is redirected from the source web server, such as when they click a hyperlink. The header is available to allow a web administrator to control what information is shared. Here are some examples of referrer policy: no referrer, same origin, strict origin, and strict origin when cross origin. Here is the breakdown. No referrer. This completely disables any information being sent about the referrer. Same origin. This policy will only send referrer information when the destination is part of the same origin. This is helpful when you want referrer information passed when hyperlinks are within the same website but not outside the external website. Strict origin. This policy only sends the referrer as the origin when the protocol stays the same. So a referrer is sent when a HTTPS connection goes through another HTTPS connection. Next, strict origin when cross origin. This is similar to strict origin except for same origin request, where it sends the full URL path in the origin header. So these are some of the security headers for a HTTP request or a response. Now let's answer the questions. In a content security policy configuration, which property can be set to define where scripts can be loaded from? So it is script source. When configuring the strict transport security header to ensure that all subdomains of a site also use HTTPS, Which directive should be included to apply the security policy to both the main domain and its subdomain? So it is include subdomains. Next, which HTTP header directive is used to prevent browsers from interpreting files as different MIME type than what is specified by the server, thereby mitigating content type sniffing attacks? It is no sniff. Okay, let's move on to task number 10. Practical task. Making HTTP request. Click the view site button on the right to launch the static site in a split view. This is an emulator for making demo HTTP request. Using what you have learned from the tasks above, complete the questions below. In case the static site is not visible, click on the show split view button. Okay. Now let's answer the questions below. First, let's see a tour guide. Okay, from here we can change our HTTP request method. We can change the URL from here. We can send our request by clicking go, and then here we can update our get or post parameters. Okay, now the first question is make a get request to /API/users. What is the flag? Okay, so first we have to edit the URL API users, and the request has to be get. Now we can click go. Now we can see the HTTP content response given, and we can see the flag here. Let's copy and paste it. Now let's move to next question. Make a post request to API user 2 and update the country of Bob from UK to US. What is the flag? Okay. Now let's put post request and to the user number 2. Let's first see what would be the response. Okay, API user 2. We can see the response here. Now let's modify the country of the Bob from UK to US. We can add here country, and we add here the value US. We will save it and then we will proceed. Now let's send a request. Now we get that flag here. Okay, let's move on to third question. Make a delete request to API user 1 to delete the user. What is the flag? Okay, let's modify the URL. Let's change the request method to delete. Now let's send the request. We get the flag. Cool. Now let's move on to the last task, which is conclusion. That's it. You have completed all the tasks. We hope you enjoyed learning about the elements that make up web applications. Hopefully you have learned a bit more about what components are involved in web application, the structure of the uniform resource locator, what are HTTP messages, requests, headers and responses, the importance of security headers. Okay, let's click complete. Okay, this is the total walkthrough of the web applications basics room from TryHackMe. Thank you guys for watching, and if you like this type of videos, please also watch my other walkthroughs where I have explained in detail about different topics such as websites and other security related information. See you on next video.